Okay, this video is going to cover radius, diameter, and circumference of circles. First of all, we need to remember that a circle has a radius and a diameter. We're going to go ahead and write the formula for the radius in terms of the diameter and vice versa. So when we're given the radius, we need to remember the radius is half of the diameter, and the diameter is 2 times the radius. So using that, let's go ahead and take a look at number 2 and 3. On number 2, we're seeing that TU right here, the diameter, okay, so this is diameter, is 14. We want to know what the radius is. So the radius, all we have to do is follow this formula, is going to be half of that, giving us 7 feet. Now we're going to change this up and say QT right here, which is the radius, is 11 meters, so we want TU, the diameter. So the diameter, remember, is going to be 2 times the radius, giving us 22 feet. Okay, simple, short, and sweet. Take half of the longer to get to the shorter, or double the shorter to get to the longer. That's how I always kind of refer that to. Now, let's pay attention to what's going on here. In this diagram, we're told that we're going to find RC, which is going to be right here. Okay? So we got a lot of stuff going on here. First of all, they're going to tell us that circle S, this is the symbol for circle S, has a diameter of 30, meaning the entire diameter right here is 30, and in circle R has a diameter of 20. Well, we don't have the diameter, okay? So let's take a look. Let's go ahead and label DS right here is going to be 9. Now, let's find the radius of circle R. Well, on circle R, the diameter is 20, so the radius, we need to take half of 20 to get 10. So right here, the radius is going to be 10. Again, we're only looking for this highlight, so we got to figure out what's right here, okay? Now, we need to remember if the diameter of circle S is 30, that means right here, the radius, and it's getting a little messy here, is 10. Well, if we figure out what CD is, okay, we can go ahead and just focus right here and figure out what CD is. Well, if the entire diameter right here, I'm sorry, that's not 10. Rewind, sorry guys. 15, half of 30. Well, if DS is 9, well, we take that away and we're going to find out that this is 6. Okay, again, I apologize for all the sloppiness. So CD is 6, because 6 plus 9 is going to give us that radius of 15. Now we can shift over to here, and we can see here that RC right here is 10. If we take that 6 away, this is here CD, we're going to get 4. And that's, sorry, I'm rushing here. Sorry, RD was 10. We're going to subtract the 6 from CD right here, exactly what we just did over here. Okay, we're going to take away that 6 from the 10 to get 4, and that's going to give us RC. Okay, so bits and pieces, just looking at little things at a time, focusing here first, find that radius, take that 9 away from the radius of 15, and we've got to find 6. This is the segment that both circles share. So now we come over here, and with the 10 radius, we take the 6 away to get 4. All right, so now we're going to look at the circumference of a circle is the distance around the entire circle. And we've got this ratio of the circumference over the diameter. It's going to end up being an irrational number, so we use this term pi, okay? It's just old fancy words for saying this is where we get our pi from. Any circle's circumference divided by its diameter will result in the same value. This is the reason all circles are similar, okay? And so when we look at, we're going to go ahead and rearrange this equation of C over D, because we just discussed the ratio of C over D is equal to pi, okay? So C over D is equal to pi. So we're going to use this right here, and we're going to figure out these 2 different formulas, one using diameter and one using the radius. So let's go ahead and take a look first. at C over D equals pi, and let's figure out how to get the diameter. Well, in order to get rid of the C over D, let's go ahead and get C by itself, because that's our plan. Get C by itself. In order to do that, instead of dividing by D, we need to multiply by D, the diameter. That cancels, leaving us with just the circumference. And over here, this is where we get the formula of pi times diameter. All right, so let's go ahead and take this and transfer it to our other formula for circumference when we use the radius. Let's start off with the circumference is pi times the diameter, what we have here. And we need to remember that diameter, as we discussed all the way up here, is 2 times the radius. So what we're going to do here is we're going to remove the diameter and we're going to substitute in for 2r. And then this is where we get pi, well, we put the 2 first. It doesn't matter, but the formula you're going to see is 2 times pi times r, because all you're doing is taking the radius times 2 to get that diameter. So on the next page, we'll take a look at a bunch of circumference problems, starting off with just basic circumference here. Here are 2 different formulas, depending on what they give us. They give us the radius or they give us the diameter. We will be rounding to the nearest hundredth. 100 has 2 zeros, so we want 2 numbers after the decimal. So if we're given the radius, I'm going to use my radius formula right here, that the circumference is equal to 2 times pi times r. We're going to plug in for r, which was your 2.5. When we plug this, just plug it all in the calculator at one time. 2 times the pi, in the parentheses, or times 2.5. When we round this to the nearest 100, what I'm going to do is I'm going to first show you what's called in terms of pi. We'll learn this later on, I do believe. That means you multiply everything except for that pi symbol into the calculator. So 2 times the 2.5 is going to give you 5 times pi. And this rounded to the nearest hundredth, when we plug that into the calculator, will be around approximately 15 and 71 hundredths. Now using the diameter, we'll use that diameter formula, pi times d. We plug in for the diameter of 16. And then we're going to find to the nearest hundredth, we're going to get approximately 50.27, 50 and 27 hundredths. For those of you who've never watched my videos, the squiggly lines here, this is not me riding in the car and we're going over a bumpy road when I'm trying to do equal sign. That is an approximate because I'm rounding. You don't have to do that. You can just put an equal sign. Now we're going to look at finding the radius and diameter if I give you the circumference. So the first thing we look at to find the diameter is the formula using the diameter. Circumference equals pi times this diameter. Now we have C, 77.8. This will be equal to pi times d. All we have to do to get diameter, letter d by itself, is divide both sides by pi. We're going to come back to the 77.8 over pi in just a moment, okay? So when we divide, these are going to cancel, and we end up with d on the right by itself. When we plug this into the calculator, we do want to the nearest hundredth. Again, 2 numbers after the decimal. Pay attention to the third, rounding rules. We're going to end up with approximately, and I didn't do my approximate sign, no big deal, 24 and 76 hundredths. Now to find the radius, I'm just going to use the diameter, okay? But I'm not going to use the rounded one. I'm going to use this guy right here. So I have more of an exact number. So your radius is going to be half of the diameter. So if I plug in, go ahead and use the 77.8 over pi. And so all we have to do in the calculator is type in 1/2 parentheses 77.8 over pi. And your radius to the nearest hundredth will be approximately 12 and 38 hundredths. So now we need to talk about inscribed and circumscribed. The word inscribed is going to mean inside. So here, I want you guys to put in parentheses, inside. So if a polygon is inscribed inside of a circle, that means all the vertices or angles of this polygon are going to be on that circle. So look at the circle. The quadrilateral inside, all 4 vertices lie on top, or on that circle, so it keeps it inside that circle. A circle is circumscribed, okay? Think about, circumference, we're going all the way around, okay? So your circumscribed is going to mean around. And a circle is circumscribed about a polygon if it contains all the vertices. It's just saying the complete opposite, meaning all these vertices are on the circle, so the polygon is inside, so the circle is outside or around it. So here we take a look at quadrilateral LMNP is inscribed in circle K. Here's circle K. So the quadrilateral is inside of the circle. And then vice versa, the circle is circumscribed around, outside of the quadrilateral. Okay? So this is now where I was telling you earlier about in terms of pi. What all this is letting you know is that when we have an exact value, this is not rounded. If we plug pi into the calculator, pi is an irrational number, meaning it's a decimal, it's going to keep going on and on forever, but not repeat. There's no end to it. And so if we have 2 pi centimeters, this would be an exact circumference because we did not plug pi into the calculator. This has a radius of 1, meaning the diameter of 2. So it's diameter times pi. This is what we call, what I said earlier, in terms of pi. So if you're asked to the nearest tenths, hundredths, you'll put pi into the calculator. If I ask you for exact, then, or in terms of pi, do not plug pi into the calculator. You plug everything else into the calculator if you need to, okay? And the last part here says that if you multiply 2 times pi, you're going to get that decimal. So you don't have exact. We have a rounded. So basically the big thing is focus on, do they want the exact measurement? That will be in terms of pi. So we're going to go ahead and do that for both of these problems. Now on letter A, we're going to notice we have the opposite of over here. Here we have the square is circumscribed, meaning the square is outside. And the square is going to have a side length of 14. Well, if we transfer into the inscribed circle inside, that side length is going to become the diameter of the circle. So if we take a look at the circumference with the diameter formula, it's pi times diameter. What we're going to do is we're going to go ahead and plug in 14 for the diameter. Because I want the exact, or in terms of pi, we're done. But the way we write it is the pi symbol always comes afterwards. So we're going to switch these two around, and this will be 14 pi. And that's going to be that's all you do here. Okay? So we're going to take a look at B now. On B, we have an inscribed right triangle. Triangle inscribed inside. So we have a right triangle, so we need to make sure we put our 9° here. It's got legs of 8 centimeters and 12 centimeters. So we want to find the exact circumference. Well, the problem is we don't have the diameter. So the hypotenuse is the diameter. So we need to use Pythagorean theorem to figure out what our diameter is. So are there a squared plus b squared equals c squared? We're looking for c, the hypotenuse. So we'll plug in 8 and 12 for a and b. 8 squared plus 12 squared will equal c squared. We're going to square our two numbers. We're going to add them together. And then we're going to leave it in the simplest radical form. We're going to have to go simplify it. This square will cancel out that square root. And for those of you who've never seen my video, there are several ways to simplify radicals. I like to use what's called a division tower. It's using your prime numbers. I start at the bottom, and we start dividing by the smallest prime number possible, 2. We get 104. We keep building that tower, dividing by the smallest prime number until we can't anymore. We divide 52 by 2. We're going to get 26. We can still divide by 2. We're going to get 13. When you're left with a prime number up top, you're done simplifying. So now we're going to go ahead and look at our partners. Here we have a partnership of 2, so it's going to go outside the house. Here we have another partnership of 2 going outside the house. And then we have this leftover 13 that stays inside the house. This is going to give us our diameter right here, or C, is going to end up being 4 square root of 13. So all this work to find the diameter. Let's go ahead and figure out now circumference. We have our diameter, pi times diameter. We're going to plug in for diameter, and we're going to leave it in terms of pi or exact. We're not plugging in the pi symbol. So we have pi times your diameter of 4 square root of 13. So if you leave it as pi 4 square root of 13, I know that I'm not too particular what order you put everything in. Technically, it gets a little weird. Pi is supposed to be part of this number outside. It's 4 pi square root of 13. But again, if you put pi 4 square root of 13, if you put 4 square root of 13, I'd be very careful with this last one. I would not do that because you don't want to end up accidentally doing this. Don't do that. So I would not recommend this version. But either one of these versions will work in my class. So rather than just finding circumference, we're looking at working backwards as well as learning in terms of pi or your exact.